Hello dear students, how are you? Hope you all are safe and fine. So today my topic is the current electricity, and the main topic I will discuss with you, that is drift velocity. So very important concept from the board point of view also. So first of all, let's see what is the drift velocity. Then I will derive the expression for the drift velocity, based upon which short questions can be framed. So see, in metallic conductor, we know that there are a large number of free electrons, and these electrons are in random direction. Okay, so on an average, we can say that if there are n number of electrons and having the velocities as u1, u2, and so un, so on an average, the velocity will be 0. So we can say that there is no electric field. So I am just discussing at the room temperature. So at room temperature, I can say that the n number of electrons are moving randomly in all directions. So on an average, if I discuss of the average velocity, that will come out to be 0. But now thing is, what is going to happen when we apply the electric field? So as soon as you apply the electric field, initially is all the electrons are moving in random directions, but as soon as we are applying the electric field, what is going to happen? So all electrons start moving in a particular direction. Okay, that is opposite to the direction of the electric field. So means as soon as the electric field applied, the electrons get accelerated under this applied field, and this acceleration, or we can say that electron gains some velocity, and that gaining in velocity is for a very short duration of time, because you know that there are huge number of free electrons, and obviously as soon as electric field is applied, the collision rate is also increasing. So this additional velocity will last for a very short interval of time. So ultimately, the gain in the velocity that is acquired by the electrons under the applied electric field, that is called as drift velocity. So if I come with the exact definition, it is the average velocity with which free electrons in a conductor get drifted in a direction opposite to the applied electric field. So this becomes the exact definition for drift velocity. So now we need to derive the expression for the drift velocity. So already I said, whenever you apply the electric field, electrons start moving in a direction opposite to the electric field. That is, a force is being exerted on the n number of electrons. So in general, I can say that the force exerted being given as F equals to minus E times capital E. Small is the charge and capital is the electric field, and negative sign indicates that we are discussing the acceleration of the electrons in opposite direction to the electric field, right? And this, of course, I am saying that this occurs for a very short interval of time, and that time is also called as relaxation time. That interval is also called as relaxation time. That is time interval between two successive collisions. Time interval between two successive collisions is called as that is between electrons and ions in a lattice is called as relaxation time. Okay, so we can say that this is denoted by tau. We can say that the electrons get drifted, or electrons gains some additional velocity for this particular interval of time, that is relaxation time, tau, right? So ultimately, the drift velocity concept and the relaxation time are correlated to each other. So now see, we are starting with the expression of the drift velocity. So we have a basic equation, V equal to U plus AP. So V, that is drift velocity, Vd. U is the initial velocity, and plus A times tau. Tau is the relaxation time. Okay, and initially I can assume all the electrons to be assumed to be at rest. Right, initial velocity is assumed to be 0, while acceleration can be written as minus E divided by m, right, that is F equal to ma. From here you can take the value of A, multiply by tau. Okay, then ultimately if I take the magnitude Vd, it will come out to be positive value if I take only the magnitude E tau by m. So this is one expression for drift velocity. So you can say that drift velocity depends upon the relaxation time, mass of the charge carrier, applied electric field, charge of the carrier. So all these parameters will decide about the value of the drift velocity being gained by a charge carrier in the presence of electric field. Right? And related to this concept, one basic term is also called as mobility. So mobility is a very basic term. That is, we generally say that electrons are more mobile as to the positive charge particles, because of being a lesser mass. Right? The mobile is, that is, movement of the charge carriers. That is called as mobility. Okay, and mathematically it is denoted by a symbol nu. And it's given as drift velocity divided by electric field E, that is Vd divided by E, right? And if you put up the value of Vd, that is E tau by m, put up the value of Vd here divided by E get cancelled and you will left with E tau by m. Okay, so this is the expression for mobility, and you are seeing that it's inversely proportional to mass. So we know that electrons have less mass as compared to protons or positively charged particles. So lesser the mass, higher will be the mobility. So there again comes the answer why we always say that electrons are more mobile as compared to the positively charged particles. So we can verify mathematically also it's inverse to the mass m. So this is the concept of drift velocity, relaxation time, and one term I have introduced, that is mobility. So I hope you have understand all the terms. So in my next topic I will continue with concept of the correlation of drift velocity with the current. So meet you in the next class. Take care. Bye bye.